Now we want to develop here the equation for velocity ratio, and it is defined as the speed of a driven pulley, that is the follower, to the driver pulley. So here if I say that N1 is the rotational speed of a driving pulley, and let's assume that the pulley is rotating in the clockwise direction with a rotational speed equal to N1, then because of the open belt, the follower or the driven pulley will also rotate in the same direction with a speed equal to N2. Let here D1 represent the diameter of the driving pulley and D2 represents the diameter of a driven pulley, and T represent here the thickness. So this one is representing the thickness of the belt T. If we assume that the thickness of the belt is very small, we can neglect the thickness T. In that case, we have linear speed of a driver is V1 is given as pi into D1 into N1 divided by 60. And suppose V2 represent the linear speed of a driven. In that case, we have linear speed V2 is equal to pi into D2 into N2 by 60. Since the linear speed is same, so we have V1 is equal to V2. In that case, pi by 60 will cancel out, and we have D1 into N1 is same as equal to D2 into N2. As per the definition of a velocity ratio, it is a ratio of the speed of a driven pulley, that is N2, to that of a driving pulley. So in this case, we have velocity ratio VR is given as N2 by N1 is same as equal to D1 divided by D2. You will get this expression if we neglect the thickness T. But if the thickness is considered, then you have to select the mean diameter here. So mean diameter is shown by the dotted line. So total thickness is T by 2 and T by 2. So I will just show here the approximate value of the mean. So from this dotted line to this dotted line, so we have D1 will be modified and it will be D1 prime, which is same as equal to D1 plus T by 2 plus T by 2. So this is the difference when if the thickness is considered. So in this case, we have D1 prime is same as D plus T by 2 is D1 plus T. Similarly, we can calculate D2 prime will be D2 plus T. So only the value of D1 will be replaced as D1 plus T and D2 is replaced by D2 plus T when the thickness is considered. So velocity ratio, if the thickness is considered, is given as N2 by N1 is equal to D1 plus thickness of the belt T divided by D2 plus the thickness of the belt T. So this equation you have to use if the thickness is considered, and if the thickness is neglected, force the value of T is equal to 0, you will get VR is equal to D1 by D2. When we have equated V1 is equal to V2, it is called as no slip condition. And if we consider the slip between the belt and the pulley, in that case the value of V1 will be higher value as compared to velocity V, which one is the belt velocity is greater than the velocity V2. Previously we have assumed the velocity V1 is equal to V2 is same as equal to V, where V represent the belt velocity. So in a belt, if we consider the slip, in that case the velocity V1, which one is a linear velocity of a driver pulley, V2 represent the linear velocity of a driven pulley, and V represents here the linear velocity of belt. In that case, linear velocity of the driver pulley V1 is greater than the belt velocity V is greater than the linear velocity of a driven pulley. So in this case, we have to define the slip. So we define the slip as the relative motion between the belt and the pulley surface due to insufficient frictional gap. This gap is filled between the belt and pulley by air. So because of the air layer present between the pulley and the belt surface, we have a certain amount of slip will occur, and this slip is normally expressed in percentage. So here we observe that the linear velocity of the belt is less than the linear velocity of a driver, but more than the linear velocity of a driven pulley. Hence, in presence of slip, the belt moves somewhat slower than the driver pulley but somewhat faster than the driven pulley. So there is a relative difference between the velocity of the belt, velocity of the driven pulley and the driver pulley. So in the presence of a slip, the speed of a follower decreases, and hence the velocity ratio of a belt drive and efficiency of the belt will decrease. So we know that here the velocity of the belt is lower than the velocity of a driver. Suppose S1 represent here the percentage of slip between the driver pulley and the belt. In that case, we can calculate the linear velocity of the belt as V is equal to V1 minus V1 multiplied by percentage is S1 divided by 100. That will be same as equal to V1, which one is common, is 1 minus S1 divided by 100. Now the speed of a belt is higher as compared to the driven. Suppose S2 represent here the percentage of slip between the driven pulley and the belt. Since here the velocity V2, that is the linear velocity of a driven pulley, will be less than the velocity of belt. So we have V2 is equal to V minus V multiplied by S2 divided by 100, which is same as equal to V into 1 minus S2 by 100. In the first case, the velocity of the belt is a lower value as compared to the linear velocity of a driver. So we have subtracted the quantity V1 into S1 by 100. In the second case, the driven velocity will be lower as compared to the belt speed. So we have V2 is equal to the velocity of the belt minus the amount of percentage we have to subtract. But as far as the linear velocity of a driver pulley is considered, it is including the thickness. This value is given as pi into d1 plus t multiplied by n divided by 60. And the linear velocity of a driven pulley, considering the thickness, is given as pi into d2 plus thickness of the belt. This one is n1 and this is n2 by 60. So using these two equations, and we can substitute here for V from the equation 1. So from 1 and 2 we get V2 equal to, so this value of V2 is equal to V, and V is equal to V1 into 1 minus S1 by 100 multiplied by this term, which is same as equal to 1 minus S2 by 100. Actually percentage is very small. S1 and S2 is a very small value. Here we can replace the value of V2 as pi into D2 plus thickness into N2 by 60. So V2 is replaced as pi into diameter of a driven pulley plus we have thickness T multiplied by rotational speed of a driven pulley divided by 60 is equal to V1 we can replace as pi into D1 plus T. So we have pi into D1 plus T into N1 divided by 60 into, this time we'll expand the bracket, 1 into 1 is same as equal to 1. 1 multiplied by minus of S2 by 100 is same as S2 by 100 minus S1 by 100 into 1 is minus S1 by 100, and minus become plus. We have S1 into S2. This product is already small, divided by 100 into 100, that is 10 to the power 4. So practically this last term is very small amount, so it can be neglected. Secondly, pi by 60. Pi by 60 will also cancel out. And we develop the equation for velocity ratio as Vr is equal to n2 by n1. If you take n2 by n1, we will get d1 plus t, diameter of a driver pulley plus the thickness of the belt divided by the diameter of a driven pulley plus thickness of the belt multiplied by this extra factor come because of slip, so is 1. This time here 100 is common and minus sign will take it common, is 1 minus s1 plus s2 divided by 100. So in this fashion we can calculate Vr if the slip is known. Suppose we say that the S is the total percentage slip, which is equal to S1 plus S2. In that case, we can have the velocity ratio Vr is equal to N2 by N1 is same as the diameter of a driver pulley plus thickness divided by diameter of a driven pulley plus thickness multiplied by 1 minus S, which one is the total percentage slip, is nothing but S1 plus S2 is divided by 100. In this fashion we can calculate the velocity ratio when the slip is given. If the slip is not given, in that case suppose the value of S equal to 0, then you reduce the equation Vr is equal to N2 by N1 is equal to D1 plus T divided by D2 plus T, and if the thickness is neglected, then you pose the value of T is equal to 0. You get a very simplified form of the velocity ratio N2 by N1 is equal to D1 by D2. So remember this ratio of velocity ratio, that is N2 by N1 is equal to D1 plus T upon D2 plus T. If thickness is neglected, then use the value of T is equal to 0. If the slip is neglected, use the value of S equal to 0. In this fashion we can calculate the diameter of a driver pulley for the required velocity ratio. The video you are watching is from the app, which is the Mohod class app available on Google Store, and in this app we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.